Assalamualaikum warahmatullahi wabarakatuh and a good day. My name is m.najmi Bachelor and I am here to present about the lab or experiment about the Archimedes principle. Introduction. The Archimedes principle theory states that a body that is wholly or partially submerged into the water is opposed by a force equal in magnitude to the weight of the fluid displaced by the body. Now, this is the diagram. If we look at the diagram, the weight of the object is opposed by the buoyant force, but this only happens in liquid or fluid. In other matters such as air, it does not happen because there is other weight. There is only gravitational weight. Now, the force is called buoyant force. When an object is submerged into the fluid, its weight will be decreased equal to the buoyant force that is exerted on the object. Now, our method is the direct measurement of mass that will measure the weight of the object where it is in the air and also in the water. The buoyant force is equal to the weight of the object in the air minus the weight of the object in the water. The weight of the object in the water will be reduced due to the buoyant force. So, by subtracting both of the weight of object in air and water, we will get the buoyant force. Now, our objectives of this experiment. The objective of the experiment is to investigate how the density of different liquids affects the buoyancy acted on the object. This is our diagram of experiment. Now, we are using weight scale here to measure the weight of the object in the water only. If we want to, the measurement of the weight in the air is using electric scale. Now, our equipment and apparatus. First, a spring scale, then a 10 ml beaker, a solid cylinder metal, a spill can, a digital balance or electric scale, water, oil, alcohol, and paper towels. For our methodology, first is measure the mass of the weight using the digital balance and determine its weight. Second, pour water into the 250 ml beakers. Attach the weight to the hooks of spring scale and lower them carefully into the water until it is fully submerged. Make sure that the weight does not touch the beaker as it can lead to error. Now, the weight of the weight were measured using the spring scale while they are submerged in the water, and then the buoyant force was calculated using the weight of object in the air and the weight of object in the water. This experiment was repeated by replacing the water with alcohol and oil, and the apparatus were cleaned up after the experiment. Now, there is a second part for our methodology, that is to calculate the density of the liquid used. First, put a 10 ml cylinder on the electric scale and zero the scale. Pour 10 ml of water into the cylinder and take the reading from the electric scale. Calculate the density of the water by using the formula ρ equal to mass over volume. Take note that the formula in this slide is the V is capital V, not small v. Now, M is the mass of the water and V is the amount of liquid poured. Repeat the experiment by replacing the water with alcohol and oil. Our results and calculations. At here we can see that the weight of the objects is same throughout the experiment for both three liquids, that is 179.3 grams. But the weight of the object in the water varies. This we will discuss in the calculation. The volume of liquid used to measure the density also same throughout the experiment, that is 10 ml. Now, our buoyant force. Our buoyant force is calculated by subtracting the weight of the object in the water with the weight of the object in the air, and our density is measured by using the mass of liquid over the volume of liquid used. Our discussions. Alcohol had the lowest density of all at 0.87 gram per milliliter, while water has the highest density. Now, the effect is the object weigh more in the alcohol than the object weigh in the water or oil. This is because lower density will lead to lower buoyancy force. There were human errors in the experiment since the eye are not perpendicular to the scale of the weather to the scale of the spring scale. Our conclusion. Based on this experiment, we can derive two conclusions. That is, first, the density affect the buoyancy force. Second is, the higher the density, the higher the buoyancy force. That's all from me. Thank you.